So we have three different types of energy transfer. So all three of these.
Good afternoon. Here today's announcement. High schoolers, please do not forget that this is the last week to purchase tickets in both your teachers' beer designs. 2 tickets are only for $1, so come on, we can do this. There will be no cheerleading practice today. I repeat, there will be no cheerleading practice today. It is a season of giving, so don't forget to bring in your cans for our 3rd annual food drive. Thanksgiving is approaching. Let's get it. Are you against all forms of bullying? Think before you post. If you want to truly take a stand against bullying, sign the banner outside the library. Signature price for a bracelet too. Attention all sophomores. If you are going on the trip next Tuesday, you must bring in your permission slip tomorrow, Friday, November 21st, to Ms. Bastedas. Thank you. There will also be a potluck dinner tonight at 6:30. Keep shining, Falcons.
Okay, so conduction, radiation, convection, all three of those are different ways that we can transfer energy from one place to another. But the way that they do it is a little bit different for each one, right? So for conduction, what do I have to do if I want to conduct energy from something? Francis? Contact? Yeah, you have to contact it, or another way to say that is you have to touch something, right? So, I know, I'm coming back, just calm down. Okay, so right here I have a beaker. There you go. Right here I have a beaker and it's on a hot plate. The hot plate is on and it's making the metal plate right here warm, or hot actually, it's very hot. What that's doing is through conduction, because the glass is touching the plate is sending the heat from the plate to the glass, and then in another part of convection, the glass is sending the heat from the glass into the water, and that's what's heating up my water right now. On the flip side of that, I have ice in a beaker, and that's also cooling by the process of conduction, because the glass feels cold and the water is getting cold because the ice is touching the water. That's conduction. The next one is radiation. So does anybody remember what radiation is? How the energy gets transferred from radiation, Nana? Good. So this is through wave after wave, wave after wave. Come on, I heard. Nothing. A couple. Okay, I heard a couple. You got a couple. You remembered? Slowly drifting. You never shut up, guys.
I remember.
Right. So let me see if I can make this happen. I don't know if you guys can see that there's some steam coming off of this. Well, if you can or you can't, yeah, it's not really that impressive right now. No, because it's white steam. That doesn't make sense. So the steam coming off of this, right? Or even if you hold your hand above it and I can feel the heat coming off of it. So that's radiation because it's traveling through waves, right? When we think of heat waves, we think of like this snake pattern, right? And you can see that happening here. So that's the radiation part, where it's radiating the energy up. So those two are great. However, in earth science, there's one type of energy transfer that reigns supreme, which is the process of convection. So can somebody remind me what the process of convection is as far as how it transfers its energy? Does anybody recall that from Tuesday by any chance? Just now? You want to take a shot, Adrian?
Motion?
Yeah. Specifically triggered by differences in density. That's the important part. It's triggered through motion, but the motion is because of density differences. Right? And density, And density is how much matter is in a given space. So by density, right, if we have 2 blocks and each X represents a molecule, which one has more molecules packed in about the same size cube? I mean, I'm not the best artist in the world, but just by show of fingers, is it 1 or is it 2? Which one is higher in density between 1 and 2? So again, it's the amount of stuff packed into a specific space. So the more stuff that's packed, the higher the density should be. So just either a 1 or a 2, 1 or 2, 1 or 2, 1 or 2. So I have 4 people that, nope, I have 3 people and a fool. 2 more. All right, 1, good, good. Yeah, so this one is higher. This one's higher density because you're packing more molecules into a space than this one. This one is lower in density because you have a lot less stuff in that same space. Again, if I was a perfect artist or if I was smart and I just used the smartboard tool that draws squares for me, I would have made both of these boxes the same, but it is what it is. All right, so I have 2, these are called beakers. So I have 2 2,000 milliliter beakers. I also have some extra stuff that I ended up picking up along the day just to make things easier with myself. Blue and green food dye, so that's already in the 2 beakers with the hot water being heated up on the hot plate and the cold water obviously with the ice. 2 small glass jars. I switched out the jars for these tiny little flasks. These are for very small scientists, whereas this one's for medium-sized scientists. And then last but not least, I have the stoppers. So these are just little rubber plugs that will go on the top so the water doesn't escape as I drop it. So what I'm going to do, so again, we're going to just see how temperature, so how temperature affects the density and how the density will cause motion in a liquid. So this only works in fluids. This does not work in like the table. The table does not move by, there is no energy transfer through convection. Because in order for there to be convection, you need to have the ability of that material to move. So the only phases of matter that you need to be concerned with that will do this are liquids and gases. So water will do it. Later in the year, we talk about something called the asthenosphere, which is a plastic that will move, and our air moves by this process as well. Okay, so then I'm going to put the plug over the top. And I'm going to put it, I'm going to submerge it in here. So now what I'm going to do is I'm just going to slowly remove the top. So if I take the top, right, there's water inside of the flask and there's water. This is room temperature water in the beaker. It just came out of the faucet. I mean, it's a tiny bit chilled, but it's not anything significant. What's going to happen, because there's water in the flask and then there's water in the beaker, it's going to combine, right? Okay, so I've got to do this really slowly. Right, makes sense. Mix water with water, you get water.
Oh, man. Oh, my God, he's cheating. Oh, man. Oh, man. Oh, man.
So, just give it a second to settle back down. So because I pulled it off, and I pulled it a little bit harder than I probably should have because I pushed it in there a little tightly. Wow. Did it mix? No, it didn't mix. I have cold water in the flask, I have room temperature water in the beaker. We predicted that it should have mixed in with the water and then really the whole thing should have turned blue. But that wasn't the case. So we're going to compare that now to when I do this with hot water. So again, and I know some of this did come out a little bit, but that's more because I pulled out the stopper and when the water rushed in, it like launched some of the blue water out.
This one right here.
This one.
You want to label the tiny flask as cold and the water outside of it is room temperature. So I should see a colored flask and 2 labels. cold and room temperature. Room temperature is the temperature of the room. David, write your name on this first, and then do this. Let's get moving. Okay, you have 30 more seconds to finish this. Label this. What is this? What is this?
Next version of this that I'm going to do is with water that's been sitting on this hot plate. So it's going to be the same process. So I didn't make it red even though it's hot. There's a reason for that. So I'm going to do the same thing now just with hot water. So I'm going to put this. Okay. Top, submerge, and slowly.
That's hot water in that glass. So the purpley looking water is hot water. What is the hot water doing?
That is like one of the souvenirs that you get out of Six Flags.
What do you see happening here?
So yeah, guys, so what I really want you to focus on, besides the fact that it's going up, it's staying up there, right? This part's just turning a darker blue color up here, or whatever, aqua color, right? But below here, that's still staying regular color water. So what's happening? It's just going to do what? Yeah, it's just sitting on top, right? So we have the cold water down here. That's just sitting on bottom. Hot water is just sitting on top. But now, let's make it fancy. And to put them next to each other. So, sorry. That was the cold water. That was a little bit of extra. No, that was just because I left too much air in it. Okay, and then this. Okay, so just to show it a little bit differently, let's give it some time. Again, you're going to see the blue is just going to sit there like the last time, right? And the green now is spreading along the top. I'm going to give it some time to kind of diffuse in there. So again, notice that the hot is only staying up here, right? Because it is less dense than the room temperature water. The blue is more dense, so it's not going anywhere. It's just sitting there. All right. So again, I'm just going to take a handful of ice and I'm going to put it on the side of the bucket here. So you guys see it now on the left-hand side of the screen. It's starting to sink.
See the green?
And the other side is still clear, but so this is what I want to just try and do. See what happened.
What do you think's gonna happen?
So if I can make this cold enough,